So one of the last things that we did before we all went on vacation was to begin our unit on chemical reactions, and specifically we were working on balancing chemical equations. So that's what I want to take a little time in this video to review, and we're going to start with the concept of conservation of mass. So give a little thought to that. What did conservation of mass mean? I know if I asked Fred, he would know. And I got a little bit of feedback on my new teaching assistant, Fred, and my actual real life teaching assistant, Annie, who is a wonderful, wonderful teaching assistant. I don't want her taking offense at being replaced by an inanimate Fred. But in these days and times, Fred is the best that I can do, and I really wish that Annie was able to continue helping as my teaching assistant, since she is a wonderful, wonderful teaching assistant. But at any rate, conservation of mass, I know Annie would know, Fred knows, conservation of mass means you cannot create or destroy matter. So if that's the case, then we need to be able to incorporate that into our thoughts as we begin to work with chemical equations. So in this case, we're starting with an equation. We always have reactants on the left and products on the right. So in this case, lithium plus oxygen. Remember, oxygen is diatomic, so you see it there where oxygen is not with a friend, it's by itself. We have to put the little 2 behind it. The arrow means yields or produces, and it produces a molecule called Li2O, or lithium oxide. Notice there the oxygen does not have a 2 because it's not traveling by itself, and so we balance that compound, that molecule, by charge. In that case, lithium is +1, the oxygen -2. So the 2 behind the lithium is because that's a balanced molecule. So now, if we want to better understand what that really means, we're looking at only having 1 lithium on the reactant side while we have 2 on the product side. That means that somewhere we have created an extra lithium, and if we take a full inventory, we can see that we only have, in fact, 1 lithium on the left, 2 on the right, 2 oxygens on the left, but only 1 on the right. And so this is not a balanced chemical reaction. So in order to balance it, what we do is we put a little line in front of each of the molecules on the product side and the reactant side. The rule is we can put any number in those blanks as long as it starts and goes up by 1, so 1, 2, 3. Has to be a whole number, no negatives, no fractions, no decimals. Must be whole numbers starting with 1. So by default, all of them are 1. So in this case, if we put a 2 on that far side, then our oxygens will balance, so we have 2 oxygens on each side. We need a 4 in front of the lithium because the 2 on the right side applies to both the lithium and the oxygen, so 2 times 2 is 4 lithiums, 2 times 1 is 2 oxygens. 1 times 2, 1, O2 is 2 oxygens, 4 lithiums is 4, and now as you can see, we have 4 lithiums on both sides, 2 oxygens on both sides. So again, the rules use whole numbers in those blanks, start at the left. My advice is leave hydrogen and oxygen until the end. So I've provided a bunch of worksheets for you to go in and be able to do some balancing. And then another one that we had worked with before, and I want to go through the website with you just briefly here. All right, there we go. This is ChemBalancer. All of you played the game ChemBalancer, And so remember, there's 3 levels: classic, review, and brain boggle. So I'm going to start with the review version. And so remember that we just start the game. And then what it does is it starts to, I'm going to make this a little bit bigger so we can all see it. Try that one more time. Just a little bigger if I can get it there. There we go. All right. So we always start with 1 in each blank, and then ChemBalancer draws the actual number of each atom. So in this case, we have 1 sulfur, we have 2 oxygens, and then in that product side, we have 2 oxygens and 1 sulfur, meaning SO2. So if we look at the left side and the right side, the sulfurs, we have 1 on each side. In this case, the oxygens, we have 2 on each side, so that one looks balanced, and in fact, it says that that is correct. So we'll go and we'll try one more before I leave you to yourself to go ahead and re-practice just a little bit. So again, I'm going to start with 1, 1, and 1. And so in this case, we can see there's 1 sodium on the left, 2 on the right. So I'm going to come in here and I'm going to change that to a 2. Now there's 2 sodiums on the left, 2 oxygens on the left, 2 sodiums on the right, 2 oxygens on the right. It is now balanced. Before we can go on doing additional things with chemical reactions, we always have to take care of the diatomic elements, and we always have to balance the chemical equation. So before we get going with next week's material, which will be starting into some new things, I want to make sure you have that opportunity to remember how we balance a chemical equation.